Have you ever stopped to think about how your data actually moves from one device to another? When you send a file, open a website, or connect to Wi-Fi, what's really happening behind the scenes? That invisible process is what networking is all about, and at the center of it are two critical ideas, Layer 2 and Layer 3, networking. Welcome to Bluehat Cybersec Academy. Today we're going to break this down in a simple, conversational way. No heavy jargon, no confusion, just clear explanations that actually make sense. We'll talk about what switching and routing really mean, how MAC addresses are different from IP addresses, and how all of this shows up in real-world networks you use every day. So let's start from the foundation and build this together. Why Layer 2 and Layer 3 matter in networking first. A quick bit of context. Networking is often explained using something called the OSI model, which has 7 layers. Now don't worry, we're not going through all 7. The 2 networking layers you need to understand. For this topic, we only care about 2 of them. Layer 2, also known as the data link layer, and Layer 3, the network layer. Each one has a specific job, and when they work together, data flows smoothly, both locally and across the internet. What Layer 2? Networking really does. Let's talk about Layer 2 first, because this is where switching comes in. Layer 2 networking focuses on communication inside the same local network. How devices communicate? Inside a local network. Think of it like people talking within the same room or building. The role of MAC addresses and switches. At this layer, devices use MAC addresses. Data is sent as frames, and the main device doing the work is a switch. A switch doesn't think about the internet. It doesn't care about destinations across the world. Its only concern is which device is connected to which port on the local network. How switching works. Step by step. Here's how switching works in plain language. When a device sends data, the switch reads the destination MAC address. It then checks its internal MAC address table, and once it knows where that device is, it forwards the data only to the correct port. Why switching is fast and efficient? Because the switch doesn't broadcast the data everywhere, this process is incredibly fast and efficient. Now, picture this in a real-world setting. Imagine an office. You send a file from your computer to a coworker. Both of your computers are connected to the same switch. The switch already knows where each device is, so it sends the data directly to your coworker's machine. No router is involved, no internet traffic, just clean, local communication. That's Layer 2, switching in action. Now let's move beyond the local network and talk about Layer 3, which is where routing comes into play. Layer 3 is responsible for moving data between different networks. At Layer 3, devices use IP addresses. Data is sent as packets, and the main device doing the work is a router. If Layer 2 operates within a neighborhood, Layer 3 connects entire cities, countries, and even continents. So, here's how routing works. When data needs to reach a device on a different network, the router looks at the destination IP address. It checks its routing table and decides the best possible path for the packet to take. The packet is then forwarded to the next router, and this process repeats until it reaches its final destination. Think about what happens when you open a website. Your device sends a request to a server that's often thousands of miles away. That request goes to your router, which then forwards it across multiple networks. Eventually, the data reaches the web server, and the response travels back along a similar path. None of this would be possible without Layer 3 routing. At this point, the difference between switching and routing becomes much clearer. Switching, which happens at Layer 2, works inside the same network. Routing, which happens at Layer 3, works between networks. Layer 2 uses MAC addresses. Layer 3 uses IP addresses. Switches are extremely fast, while routers take a bit more time because they make more complex decisions. Now let's simplify MAC addresses and IP addresses, because this is where many people get stuck. A MAC address is a permanent, hardware-based address assigned by the manufacturer. It's used only for local communication. An IP address, on the other hand, is a logical address. It can change, and it's used to identify devices and networks globally. Here's an easy way to think about it. Your IP address is like your city and street name. Your MAC address is like your house number. Data first travels to the correct city using the IP address. Once it's there, the MAC address makes sure it reaches the exact device. You can see Layer 2 and Layer 3 working together everywhere. In a home network, a switch connects your phones, laptops, and smart TVs, while a router connects your home to the internet. In an office network, Switches connect employees and workstations, and routers connect different floors, departments, or branch offices. In data centers and cloud environments, Layer 2 handles internal server communication, while Layer 3 routes traffic across regions and countries. There's also something called a Layer 3 switch, which kind of combines the best of both worlds. It switches traffic like a traditional switch and routes traffic like a router. This is especially useful in large enterprise networks where, performance and speed really matter. From a cybersecurity perspective, this knowledge is incredibly important. Understanding Layer 2 and Layer 3 helps you detect attacks like ARP spoofing, recognize IP-based threats, design more secure networks, and troubleshoot problems faster and more confidently. Strong networking fundamentals are a must for anyone serious about cybersecurity. So let's wrap this up. Layer 2, switching moves data within a local network. Layer 3, routing moves data between networks and across the internet. Once you understand how these two layers work together, networking stops feeling mysterious and starts making sense. Thanks for watching Bluehat Cybersec Academy. If this video added value to your day, give it a like, share it with someone who could benefit, and subscribe for more content on networking, cybersecurity, and real-world tech skills. Keep learning, keep exploring, and I'll see you in the next one.